All right, question 38. So we're going to take that 12 to the other side and just kind of move it out of the way. So, because it's bugging us for right now. 2, go. Yep. All right. We got 5x squared minus 25x. What is b squared? Okay, let it go. All right. Let's do an ELSA and let it go. Okay, seriously. Okay, b squared over 4 times a. What you got? Yeah, I know that's 625 on the top, and that's 20 on the bottom. Does that reduce? Please tell me yes. What is it? Come on, what fraction? Okay, for those of you who don't realize this, okay, let's do this in slow motion. All right? We have 5 times 5 times 5 times 5 on the top. Yes, folks, that's 25 squared. I know I got rid of the negatives because there's 2 of them, but I'm hoping you know that's okay. On the bottom, we've got 4 times 5. Does anything cancel out? One of the 5s does. So what do we have as far as a fraction is concerned? 125 over 4. Okay? So I'm going to erase that because I need the space. Hopefully, oops, you got to actually hit the erase tool, otherwise it won't do nothing. All right. So that's what we're adding to both sides of this is 125 over 4. Okay? You're also going to add 125 over 4. Did you? Oops, I can't spell 125. 125 over 4. Yes, that was spelling. Okay, now, 12. How do you write 12 in terms of fourths? Whoa, 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 whoa. I want to write the number 12, but have a denominator of 4. Right now it has a denominator of 1. Don't tell me it's going down. I'm pretty sure it's got to be a bigger number than 12. Oh, 48. Good call. So this minus 12 is the same thing as minus 48 over 4. I just kind of get in common denominators just because I know I'm going to be... I don't have a lot of space here on the screen, so that's why I'm kind of cramming everything together. Otherwise, I'd be, writing things out a little bit better. So on this side, I have y plus something over 4. What is that? 125 take away 48. I heard a 77. Is that correct? Because if I take away 50, that'd be 75. So if I add 2 back, yeah, that's 77. Okay. All right. Now, on the other side of this, what are we pulling out of those? That's a perfect square, but before we see the perfect square, what are we going to pull out of those 3 terms? Pulling out a 5. Folks, it's not a GCF. It's just that first coefficient of the squared term. Now, it comes out nicely out of the first 2. And remember, it is division, so we are dividing, dividing, dividing. I thought I chose green, because now it's all... I was trying to get, something different. Oh, now look what I did. Hit the erase. Okay, 5, 5. Now, instead of saying division by 5 on the last one because it's a fraction, what if we said multiplication by the reciprocal? That would be multiplication by 1 over 5. 1 over 5. So what is 125 over 4 times 1 over 5? I'll let you discuss it while I save our lives by getting this gold stuff out so we don't die. Come on, don't right over 4 times with this. What? 25 over 4, thank you very much, because 5 goes into 125 25 times. So that is 25 over 4. Okay. Now, what perfect square are we dealing with? I'll do the hard part, folks. X. What do you got? What are you going to do with this to get to that? You're going to cut it in half, right? Speaketh the fraction. I know you want to say 2 1/2. Come on. Say it in a fraction. Minus 5 over 2. I'm so proud of you. Nice job. By the way, if you take 25 over 4, take the square root, you get 5 and 2. In case that would help you. Okay? And for our last trick, we got to get y by itself. That would be y equals 5 parenthesis x minus 5 halves quantity squared minus what? 77 fourths. Isn't it beautiful? Watch what you say, right? Because the red pen of death is listening. Thank you. I know that you don't like fractions. Okay, I know that fractional racism is alive and well in America, but you have got to get over it. Okay, people are very, very eager to say how much they hate fractions. Okay, it's very, very violent the way they talk about fractions these days. Okay, so whoa, looks like I lost part of a 5 there. Whew. I know you got to get over the whole fraction thing. The process is still the same. I added b squared over 4a. I pulled out the 5. I simplified the perfect square. I know you don't like it, but those are actually kind of some nice numbers. We could get some nasty ones. But these are actually decently nice fractions compared to others. Anyway, so there's 38. And is there any other homework question before we move on? One of these days soon, I might have you watch a video for homework at night because I feel like I want to get caught up a day here because it seems like we spent too much time on 2-1, but that might be a homework night where you guys watch a video and take some notes so we're ready for the next day. Oh, that's... So what you're saying is we have to do it 2 days. Okay, all right. Okay, is that it? Any other homework questions? We got it recorded so you can watch it. It's 38 and it was completing the square one, so... Okay, so that's it. You guys are all good on the rest of that stuff. Glad you checked the homework with your answer sheet online. That was a smart idea of you that you had there. And so now we need to move to the next section. Actually, you know what? Okay. Power functions. It's a new type of function. The definition is this one right here. Y equals k times x to the a power, where k and a are non-zero constants. I'm asking you to discuss this with your friends nearby. Unless you have no friends, then you should find some. Okay? Unless they moved away. Okay? You need to discuss with them whether you think y equals x squared fits that definition. Okay? If you do think it fits that definition, what do you think k and a are? If you don't think it fits that definition, then tell me why not. Go. Does it fit the definition, yes or no? Yes, it does. What is the K value? K is equal to 1. A is equal to 2. Are those both non-zero constants? Okay, you have a winner. Y equals x squared. Is it a polynomial? The last section we dealt with was talking about polynomials. Does y equals x squared fit the category of a polynomial? Let's see what that nasty formula looked like at the beginning of that section. Somewhere way back here. Does y equals x squared fit that particular definition? It sure does. It's a very simple polynomial, but it's a quadratic polynomial, so it fits in two different groups. It is a power function and a polynomial. Do you think every polynomial fits in the power function category? Yeah, I would agree with that. Not every polynomial fits in that. Do you think every power function fits in the polynomial category? Remember, A is a non-zero constant. Now, what do you know about the exponents from this? What do you know about the exponents? They have to be what? Non-negative integers. Now, that's specific. We go over here and it just says non-zero constant. Can you think of a number that is not an integer that would be a non-zero constant? 1/2. That's an easy one. So these two groups, the power functions and the polynomials, are overlapping groups. There are some functions that are in each group, but there's a large majority outside that they have all on their own that they don't share with the other group. Okay? But there is some overlap. Now, the K value there, we actually called that the constant of variation. Looks like they misspelled the word constant. We all know that. The constant of variation, K. We will use phrases like varies directly, varies inversely. Those are phrases that you've used before in Algebra 2. Now, the phrase that you see right here is proportional to. Is very similar to this, varies as. Okay, now, they need to be more specific. Okay, we use terms like varies directly or varies inversely. Now, do you remember what varies directly and varies inversely mean? Okay. Right here is an example of the circumference formula. Circumference is 2 pi times the radius of a circle. As the radius of a circle gets bigger, what happens to the circumference? It also gets bigger. That's called a direct relationship. As one variable is getting bigger, so is the other one. Okay, that's a direct relationship. How about you go to the gas station? The number of gallons of gas that you decide to buy, and compare that to the total bill. As you buy more gallons, what happens to the total bill? Goes up. Right, that's a direct relationship. Okay? Very simple one. It's a linear relationship. And the slope of that line is what? You're at the gas station, folks. What's the slope of the line? Isn't it the one on the sign, the big electronic sign that keeps changing, keeps going up, and you're frustrated? Because you're like, doggone it, should have bought yesterday. Inverse relationship. Inverse. As x gets bigger, what happens in an inverse relationship? Y gets smaller, right? For instance, what if there were 100 cars on a parking lot, and you're the only person that has to wash them all? Okay? Now, assuming that you and everybody else that helps is of equal work ethic and ability level. What if there's 2 people? As X is getting bigger, as you bring in more people, what if there's 10 people? What if there's 100 people? The time is getting less, right? So that's an inverse relationship. Okay? Some things are direct, some things are inverse. The constant of variation they show you in the circumference formula. The constant of variation is actually 2 pi. That's the K right there. The K for the area formula is right there. Force of gravity problem, they don't specify what K is, or Boyle's law in those particular problems. You'll notice that they have exponents which are negative. That's because I could write this K times d to the negative second if I wanted to. Or, for instance, this one, K times P to the negative first. Where? K divided by, I don't see a K divided by. Oh, yeah. So, so Boyle's law, typically we would see it written like that. They just chose to write it horizontally. Maybe to save space, because they're cheap. I don't know. Not sure on that one. So direct variation would be K times something. Inverse variation would be K divided by something. Now, what if you have something like y varies? What if y is varying directly with more than one variable? What if it was like this? Do you guys remember situations like that? They used a special word for more than one variable being directly related. What was that special word? Jointly, yes. That's referring to direct variation. It's just referencing more than one variable is directly related. You remember, maybe, hopefully your teacher last year celebrated that national holiday in Algebra 2. Right? The largest national holiday in Algebra 2 is March 14th, right? What's that one? Pi Day. Did you guys celebrate this one? National Joint Variation Day? That is on April 20th. National Joint Variation Day, where we celebrate all the directly related variables. National Joint Variation Day. Thank you very much. Appreciate it. Okay, some people understand. Other people have to draw pictures of leaves. Okay. Maybe they won't get it then either. I don't know. Yes, that's a made-up holiday by me. Nobody else talks about that one. Okay, but we celebrate. Okay. Nobody's bringing in brownies that day. No. I don't trust you people. Okay. Oh, okay. All right, sorry. It's National Joint Variation Day. We celebrate all the directly related variables. I don't know what you're talking about. Example 1, writing a power function formula from empirical evidence in the laws of physics. It has been found that the period of time for the full swing of a pendulum varies. Now, I will never do this to you. I think this is crap. In this book, they say if they don't have a word in there like direct or inverse, it is assumed to be direct. Okay. I have some not so nice words to say about that, which shall not be in the video. Okay, so time varies, it should say varies directly. I will say that on a test, varies directly. I don't want there to be, it's not an assumption. Come on, it's ridiculous. All right, so how do I say that? Time varies directly as the square root. All right, I'll give you a hint. It has something to do with the square root. Now, what should we put in front of that? K. K is the ant in your family that nobody talks about. When you're looking at these problems, nobody's going to say anything about K. But you need to remember that she's there. In fact, you'll lose credit if you don't put that in there. If you're changing something from its stated English sentence into the mathematical sentence, you need to have that constant of variation K there. It's possible that more information is going to be given to you to find that constant of variation. In this particular problem, they did not add more information. All it says is express this relationship as a power function. Now, what would be another way that we could write that? T equals K times X to the what? This is what they're getting at, folks. The half power. You need to know that a square root is a half power, and a cube root is a 1/3 power, and a fourth root is a 1/4 power. That's something you need to know from Algebra 2. I know, it's taking you back. Some of these are simple. Go ahead. That's one way you can write them. You can write them that way. They just, they might ask you another question like, what is the power? And you would need to know that it's a 1/2. And so, I like your conclusion that you made. All right, so these are both power functions. So state the power and the constant of variation. So take a look at A and tell me what the power is. 1/3. Right? This is X to the 1/3 with a K value of 1. What's the power on the next one? This is going back to whether you remember your Algebra 2 days. That is X to the -2nd that you're looking at, so -2 is definitely the power. And the constant of variation? Still a 1. They didn't do anything different with that. That's kind of boring. Why didn't they do something? Why didn't they throw like a 3 or something? I don't know. Now they do say this, analyze it. Does that mean they want me to do a 10-step analysis on these things? Ooh. Interesting. Let's get a graph. What does the graph of the cube root look like? Which two quadrants is it in? Can you tell me which two quadrants it's in? 1 and 3. Yep. 1 and 3. How about 1 over x squared? Which two quadrants is that one in? It is in 1 and 2. This is a drum major's favorite mathematical model. If you're a drum major, you'll understand. Have you ever watched a drum major? Yes. They do it constantly. They're just up there directing, you know, a little 1 over x squared going on, like constant. You know, it's like, come on, dudes, get a different model. But no. It is. Yeah, now you'll be like, if you're in band, you'll be looking at it going, oh my goodness. Really?
I mean, like it's
it's a different type. Okay, all right. I'm learning stuff. That's great. Cool. Do you need to be able to look at these and tell me if they have points of discontinuity? Sure. Does the one on the left have a point of discontinuity? Nope. Does the one on the right? At x equals what? 0. It's a vertical asymptote. Does the one on the right have a horizontal asymptote? Sure, because we know that if we take the limit as x goes to infinity, what do we get? What is the limit as x goes to infinity of that function? I bet they called it something other than f. Oh, man, I screwed up. Gee whiz. Okay. Remember, we talked about taking that function. So what happens if this number gets bigger and bigger and bigger and bigger and bigger and bigger and bigger? What happens to the whole thing? Look at the picture. The picture tells you. It's getting closer and closer and closer to what? 0. That's that horizontal asymptote. Y equals 0. All those things that we've talked about, you need to know. You need to be able to do that with these functions as well.
So are you saying the limit is 0?
The limit as x goes to positive infinity is 0. Yes. Limit as x goes to negative infinity is also 0. The limit at 0, if that's what you're talking about, the limit at 0 doesn't exist because it's from the right side it's going to infinity, from the left side it's going to infinity, but there's a vertical asymptote in the middle. So, when you say limit, I need to know specifically where you're talking about.
You say limit.
As x goes to infinity, that's this way, way far on the right side of the graph. You can see that the y values are getting closer and closer. Because remember, the word limit means y value.
Could you come and look at this, please?
Sure.
Like if I did it like this. Yeah, that's fine. But I thought it was only based on the x.
So the x's are getting bigger. We're asking, what are the y's doing? And you're telling me that the y's are approaching 0.
Okay, but how are you supposed to know that it's 1?
Well, a limit, by definition, a limit is a y value. That's why I kept emphasizing that in chapter 1. Limits are y values. So, we're deciding what's going, they're telling me what to do with x, and then asking me what's going on with the y's. And by your notation right here, you're saying that x is getting big, and y is becoming 0. I like your questions. Those are good.